Good afternoon, everyone, and welcome to Parsons Technical Webinar Series and our first webinar of 2022. I'm your host, Jessica Bennett today. We have a great webinar set up that will be presented by Hayden Avera on the methods to improve O&M performance, developing, managing, and optimizing an operations program for a large-scale remediation site. So a few housekeeping items up front. We'll be keeping all phone lines muted until the Q&A session at the very end, just to keep background noise down. If you have a question, you can submit it in the chat feature at any time, but we'll hold questions until the end. You can also ask a question at the end and we can unmute you. This webinar has been approved for a PDH credit. If you'd like to get that credit, you can download the attendance form that is available in the chat feature as a file. We'll upload it again by the end of the webinar as well for anyone that can't download it. And if you have any issues downloading this form and you want credit, you can send an email to daniela.savin@parsons.com and then she can provide that form to you. And finally, this webinar is being recorded and will be available on the Parsons YouTube channel in the coming days. So quick agenda, we'll do a quick intro about Hayden Avera, our guest speaker, quick core value moment, followed by a presentation and then Q&A at the end. Hayden is a field project manager with over 8 years experience in process design, operations, and safety management in the oil and gas industry, as well as on groundwater remediation projects. He holds a Bachelor of Science in Chemical and Biomolecular Engineering from Tulane University, and he is a professional engineer. And with that, I'll hand it over to Hayden.
So we always begin our webinars with a focus on one of Parsons' core values. So the core values from Parsons are shown on the screen, but the one that I'll focus on today is surrounding innovation, because it's related to the core topic of the presentation. So the refining industry has been an industry that's just been evolving and innovating since the very beginning. But one thing that I'm going to focus on here is actually the patented alkylation process. So this was a patented process, patented in 1941 by Fred Hedderhorst, focusing on alkylation. For those who are unfamiliar with the process, so the alkylation unit is a refinery process unit designed to take cracked branched hydrocarbons and react them with double bonded olefins, and with the net goal of increasing isoparaffins and octanes for the blend into fuels products. So one of the key things that this particular patent and this process showed was that you could extend the life cycle of sulfuric acid catalyst, which is one of the key process steps within the alkylation process, and you could focus that into splitting the reaction in two, whereas the first reaction would take the higher concentrated acid and react that with whichever feedstock needed that higher acid concentration to achieve full alkylation conversion. You would then recycle that spent acid into the second reactor so that you would treat a secondary feedstock which required a less concentrated level of acid in order to achieve alkylation conversion. So the net result is, with the same volume of acid, you're able to increase the flexibility of feedstocks you can treat, thereby increasing the amount of fuels that you could get on the net end product. So obviously this was really key in World War II effort in supplying additional increase of high performing fuels for the war effort. So this is just kind of one really cool process and a great way that shows how innovation can really drive not only different industries, but obviously world events as well. With that being said, I'll step into the webinar presentation agenda here. So first, I'm going to focus on a little bit about the large-scale remediation site's history, the operations on the site, some unique challenges with it. Then I'm going to step into the core content of the presentation, which is all about how we developed our operations program, and I'll kind of step that out sequentially. And then the last thing, I'll cover some conclusions. So first, a little bit about the site history, operations, and some of the unique challenges we deal with. So shown to the right is an aerial shot of the large-scale remediation site. you can see that the site is actually situated on an active processing facility. That active processing facility is over 100 years old. It's one of the largest of its kind, and it's spread over 1,700 acres. And across that 1,700 acres, there's multiple light non-aqueous phase liquid LNAPL sources due to historic operations. The remedial goals on the site are LNAPL recovery and migration prevention and groundwater gradient control and capture. And we use pump and treat systems in order to achieve those goals. And Parsons has been leading the site operations, maintenance, and monitoring efforts since 2016. A little bit about the site operations. So across the site, we've got 26 pump and treat systems broken down into 7 well point systems, 8 French drains, 7 recovery and dewatering well circuits, summing up to 47 individual wells, and we also have a thermal oxidizer unit. Shown to the right is just a cutaway of one of our well point systems, highlighting the multiple sensitive receptors that just this one particular system is designed to protect. Overall, we send just shy of 2 million gallons per day of total recovered groundwater and trace amounts of LNAPL to the active facility's wastewater treatment plant. So a lot of systems across the site and a lot of production each day. Some of the unique challenges we handle on the site are first and foremost the facility location. So the facility, the active processing facility in our remediation site spans multiple municipalities. So we span multiple towns, and within that there are multiple sensitive receptors, residential areas, public waterways, things that are really key to consider within the site operations. Second, we're dealing with a lot of legacy equipment on the site. So the site remediation operations have been underway for north of 30 years. So with that comes the additional challenges of having to operate and maintain legacy equipment. And the third thing is our integration with the processing facility. So as I mentioned, our remediation assets are located on an active processing facility. We tie into that facility's wastewater treatment plant. So with that presents us the challenge of not having to only understand what our system operations are capable of, but we also have to understand and have a good sound knowledge of the process operations of the assets downstream of our systems at various points throughout the site. The second thing that we have to consider is every aspect of our site operations and maintenance activities have to conform to the facility policies. So the active processing facility is a OSHA process safety management regulated facility. So obviously that comes with that robust standards for standard operating procedures, how we execute and handle management of change, and even our control work. So all of these challenges are fairly unique to a site of this size, and have to be incorporated in how we operate. So now that we've kind of covered the background of the site, I want to step into the actual development steps that took place for us to revamp our operations program. I'll first talk about kind of where we started, what the improvements we identified were, and some data gaps we wanted to resolve. And then I'll step into how within our development, we sort of focused on 4 key goals, kind of outlining our charter for what we wanted the program to be. Then I'll step into exactly which reporting tools and training modifications, so overall the program development, what we actually did and implemented. And then I'll talk about how we refined those and modified our reporting tools and used the data analysis to improve them. And then I'll talk about where we hope to go from here. So first, where do we start? Kind of 3 key things we wanted to improve on and that we identified at the very beginning. So we wanted to improve our ability to see day-to-day site operations and do a quick pulse check, not only for field personnel, but also up the chain and all project stakeholders, from project management to the client. We wanted everybody to be able to quickly see day-to-day what the system status and operations were. The second thing is about communication, and that's a key theme throughout this entire program development, is improving communication. So we wanted to make sure that site operational issues and challenges were effectively being communicated, not just across field personnel, but also up the chain and the different stakeholders that support the project. You know, specifically, there was a lot of focus between operations and engineering dialogue. So engineering was fully aware of operational issues and challenges field technicians were having, and then also any critical path items to system startups and how they impacted reliability were also well understood. The last thing is we needed to improve our data analysis. So each week, our technicians collect a weekly set of process data for all of our systems across the site. So at any given week, we have a lot of process data coming in. That's all manually collected. And we needed the ability to quickly forecast and analyze that data so that we could see any operating issues that might be coming up, or if there are any opportunities for preventive maintenance ahead of unplanned shutdowns. Now that we've identified the improvements we want to make and some of the data gaps we had, I'll focus on some of our key goals. So as we were moving to developing the program and what reporting tools and training that we needed to modify, we wanted to focus on 4 key things. Again, we wanted to enhance stakeholder communication. So we wanted to create clear lines between field operations, so technicians, and our maintenance crew, between what was being observed in the field to what engineering was seeing and helping to troubleshoot, as well as what management was aware of particular issues and how it fit into the overall site strategy. We also wanted to advance the site operations visibility. So we wanted to be able for every project stakeholder to kind of know at any given time the site operating conditions, what those key risks and pertinent site information were. The next thing is we wanted to increase system site-wide availability and our proactive maintenance. So this fed right into that need to get folks completely understand what the critical path items for system startup efforts were, make sure that was clearly documented. Whoever owned that action item knew that that was a critical step in the process. So that way we could ensure all of our systems were achieving their maximum availability. And then also this would increase our ability to identify any points in time where we needed to intervene to do proactive maintenance, with the overarching goal to strive to have 0 unplanned maintenance outages. And the last thing is we had to put all this together in how we brought not only technicians onto the site, but also engineering, and how we onboarded different project personnel and documented their competency. The site had always had an operations supervisor role, but as part of this effort, we decided to expand what that role and responsibilities were. So that way they would act as the direct link between not only how systems need to be operated in the field and the technicians need to understand their role, but also how engineering could help support operations. So getting into a bit about the program development, I'll focus on our reporting tools and training. First, the reporting tools. I'll cover each one of these in more detail, but I'll cover them holistically here. So first, we created weekly operations reports. These were meant to be 1-page reports summarizing the site operations, any noteworthy items. This was feeding into that key goal of getting increased communication and easy availability for the site operations. The next thing is we developed system operating envelopes. Operating envelopes are pretty typical within industry, but in our particular case, we needed to have operating envelopes that considered 3 key factors. The first, from an environmental perspective, is a piece of equipment or is a remediation system operating and meeting its environmental objectives? How do we use our weekly data to help ensure that that's the case? The second is from a process engineering point of view. How is that piece of equipment operating in relation to where it is designed? Where is it falling in the pump curve and things of that nature? And the last thing is focused on reliability. How are we operating the system in a way that will help achieve long-term reliability? So how is it operating in relation to the temperature and pressure design settings for the piece of equipment, for instance? And how can we use our weekly data to help answer that question? And then the last thing is we began tracking and implementing our operations key performance indicators: downtime, uptime, and availability. I'll go into each one of those in more detail, but this allowed us to get quantifiable metrics to both track our year-over-year progress, but also identify any systems that were poor performers routinely. So first, focusing on the reporting tools. So shown to the right is a snapshot of the weekly operations report as we initially rolled it out. This was initially rolled out in the Q3 of 2017. This was intended from the get-go to match the frequency of data collection, so it was on a weekly basis. And overall, it was comprised of 4 sections, which I'll go into more detail, but the first being the system status, the down system expected return section, any ongoing threats and checks, and then the operating envelope analysis and breakdown. So this is a cutaway of the site-wide system status. So this is the system status check section of the operations report. And this is intended to give that quick, high-level visibility of the entire site operation. So this lets the reviewer know exactly which systems are on and which systems are off. And if systems are off, what is the reason why they're off? This is a cutaway of any down systems of what their expected return dates might be, as well as the ongoing threats and checks. For the down systems expected return section, the intended design of this was so that we could effectively understand any critical path items to any long-term project work. So for instance, the first system we see there, STFR 6A, we can immediately see that this system is down for MOC work related to the well subsidence. So the engineering team that's working on that understands that that's sort of the key critical reason that system is down. And we give an idea of its expected return date so that operations has an idea of when that system will be coming back online. Another example is we've got 3 well point systems, J137, J138, J140, all down related to heat trace work that's scheduled to wrap up towards the end of September. Having that line item called out that way allows our operations team and our maintenance team to keep an eye on that. Since we are in an area where we usually try to wrap up our winterization efforts sometime in the middle of October. Obviously, if that date starts to slip some, that'll be something that gives us the opportunity to make sure that we keep a pulse check on that so that we're not encroaching into that winterization deadline. And the ongoing threats and checks. So this section just is intended to highlight any out of the ordinary or noteworthy issues that we want to call to the team and to the project stakeholders. You know, for instance, we got a bullet in there for one of our French drains, which is just coming out of a preventive maintenance cleaning. This particular French drain was having level control issues, and the root cause out of that might have been a suspect check valve. So this is just giving a clear indication that out of that preventive maintenance effort, that's something that we need to be monitoring extra closely, collecting more data on it, and things of that nature. Finally, this is a cutaway of the operating envelopes analysis section. I'll go into the operating envelopes in more detail in the next couple of slides, but the intent of this is to satisfy that need to quickly analyze all of the incoming weekly process data. So this quickly allows the engineering team to understand of all the data that was collected for the week, how is it coming out in relation to where either we need the system to operate from an environmental perspective or where it needs to operate and ensure its long-term reliability. So it gives us a starting point to prioritize all of our troubleshooting efforts. Stepping into the system operating envelopes. So again, these were created with the focus to match the weekly data collection. An example of the operating envelopes for a particular well point system, J137, is shown to the right there. But all of our operating envelopes for each system more or less consist of 4 categories. The upper and lower limits, the excursions are defined as max and min excursions, and upper and lower targets, the plus tar, minus tar. For the upper and lower design limits, these were all upper and lower limits. They're all driven by equipment design. So this is in relation to the operating temperature design pressures for some of our vacuum pumps on the well point systems. It's also incorporates any runout conditions or minimum flow rate requirements for any of our centrifugal pumps and what those corresponding flow rates and pressures are. And then the upper and lower targets are mostly driven by remediation objectives. So, you know, how do we need that system to operate in order to achieve the required inward gradient or the required LNAPL recovery? You know, what does that average flow rate and vacuum that we see each week need to be? So I'll step into 2 quick examples here about how we use these operating envelopes on a weekly basis, just kind of highlight the capabilities that we were able to quickly get from them. So the first one is related to BLR6. This is a recovery well that's situated in the main plant area of the active processing facility. Shown to the right on top is a cutaway of the operating envelope from one weekly data set that was collected off of BLR6. Beneath that is just an aerial shot indicating where exactly BLR6 is. The system's objective is to capture legacy elnapple plume in the area, and some of the challenges related to it, there's a lot of high concentration of sulfide and sulfide-reducing bacteria in this well that leads to a lot of H2S production, which is obviously a personnel hazard, but in particular for system operations, it leads to a lot of iron sulfide precipitation, which culminates in a lot of equipment fouling and clogging. So we can kind of see on top the cutaway of the operating envelope. So the weekly data collected by the technician indicates that we've got 9 gallons a minute coming out of this particular BLR6. That's obviously a lot lower than the defined lower limit. So that requires and indicates to us right away that this needs additional analysis. So with this particular well, some of the solutions that we focused on are out of these operating envelopes were ways to combat that precipitation that led to a lot of that routine equipment fouling and clogging. So being able to quickly analyze, all right, we're well below our lower limit there. That's an indication that likely the system is beginning to clog. That helped us pursue solutions that tried to get to the root cause of that clogging. So we initially pursued chemical injection so that we could inhibit that sulfur-reducing bacteria activity. When that ultimately didn't pan out, we implemented level control changes to increase the flow rate and decrease that the rate at which the precipitation would fall out. As we rolled out these operating envelopes, we initially put this particular system on a preventative maintenance cleaning frequency of about 6 to 8 weeks. As a result of continuing to pursue solutions based off of the feedback we were getting of our operating envelopes, ultimately those level control changes, which ultimately stuck, we were able to increase the rate at which clogging would impact the system performance to about 12 weeks. So we roughly doubled the amount of runtime we get out of that particular system. The next example is for one of our well point systems, J163. So this particular well point system is located near a waterfront area on the processing facility. Again, you can see the cutaway of the operating envelope on top. There's 2 graphics showing the liquid ring vacuum pump focus here. So this particular system's objective is to prevent offsite migration to a sensitive receptor. The challenges for this particular system are we have elevated groundwater temperatures in the area, for different reasons than we see on the rest of the site. But because of those elevated groundwater temperatures, we see a lot of fouling and scaling that happens. On our site, a lot of our well point vacuum pumps are liquid ring style pumps, and they actually use recovered groundwater as the seal fluid. And with that comes a lot of challenges. In particular for 163, since we're dealing with elevated groundwater temperatures, scaling and fouling of the vacuum pumps is a key concern. So we can see from the operating envelopes this particular week, the technician, one of the key process data points they collect is actually the exhaust temperature of the vacuum pump. So they recorded about 130 degrees. It's about 20 degrees above our upper target. We know that as that vacuum pump temperature gets hotter, it increases the likelihood that we have an unplanned outage due to the vacuum pump seizing. So that helped us to be able to better forecast when we might see an unplanned outage, since we typically know that as we start to see those recorded temperatures increasing, they usually increase fairly exponentially. So we're able to use these operating envelope feedback to identify that ahead of having those unplanned outages. We also used the feedback from here to pursue a solution site-wide that we're currently in the process of executing, which is to change that seal fluid to a fresh water source and get away and move away from using recovered groundwater. Because as you can see from the cutaway pictures of one of the planned outages we took, when we started to see that temperature creeping up, you can see a lot of the black scaling present in the vacuum pump housing, as well as the vanes there. So lastly, our operations KPIs. So our operations KPIs are really comprised of 3 particular metrics: downtime, uptime, availability. Our downtime we define it as this is the % of time that the system has been down and is in a planned or an unplanned maintenance state. These are reasons that we as the OM&M team can fully control. And the uptime is simply defined as the period of time in which it's operational. And then we have our availability, which is the percent of time that's been able to operate, which is essentially the inverse of our downtime. And the reason why we track availability separately from uptime is, again, getting back to the fact that we are integrated with a processing facility. There are multiple times throughout the year where, even though our system may be able to operate, that is, it's not undergoing planned or unplanned maintenance, an asset which we tie in downstream might have an upset condition or something where the processing facility will request us to take our systems down. So we needed a way to track all of the things that we could control and track our performance to hold ourselves accountable. And the availability allows us to do that in addition to the downtime. And the uptime obviously just gives us an indication of how often the systems are online. We track these KPIs basically at two different levels. First, it's site-wide, and that allows us to get that year-over-year progression, so that way we can see how we're doing year over year and shoot to improve our performance. We also can track them at an individual system level, and that allows us to highlight which systems are having excessive downtime or which systems are having, clearly a lot of maintenance activities, and therefore might need to be of key focus as we prepare project execution plans, and maybe there's something that we need to focus on there. And pretty quickly, the insight and analysis that we gain from doing these is it again allows us to identify those worst performing systems and quantify that negative contribution to the site, to the overall site performance. And it again allows us to clearly set areas of improvement, so that way we can get concrete, quantifiable KPI targets to again keep our year-over-year progression moving in the right direction. So now I'll go into a little bit of detail what this looks like. So the operating KPIs shown holistically, the example of that is shown to the right. So this tracking it this way site-wide at a quarterly or even yearly basis allows us to kind of take a look and see how does this match up with the planned maintenance activities that we knew we had going into the year, and how does this explain any unplanned outages or any room for improvement. And this slide shows, so since we started tracking these in 2017 up to now, this shows how we can show and visualize that year-over-year progress. So obviously, since 2017, we've made a lot of moves in the right direction. You can see both the uptime and the availability are trending upward, which is exactly where we want them to be, and our downtime overall is trending down. So tracking them holistically and site-wide allows us to make sure that we're continuing to improve on our performance. This slide shows how we can use this information in the downtime specifically to identify any issues where we might need to intervene and come up with some sort of engineering solution. So although this slide shows that 2021 and 2020, there were some systems such as DW1S to the far left there, where we did incur more unplanned maintenance downtime than we did the previous year. The arrows indicate some key systems that we opted to focus on coming out of 2020 into 2021, which we did see positive results. So DW2S, DW2N, DW1N, all three of these wells we made control changes in order to increase the average flow rate there. These are all three systems that again have issues with clogging. BLR4 has similar issues as BLR6 as the previous example we discussed a couple slides ago. Again, we see the drop in unplanned maintenance because the same solutions that we pursued for BLR6, we pursued for BLR4 as well, in order to extend the runtime and decrease the likelihood of unplanned outages there by increasing the average flow rate out of that system. And STFR7B was another system where we targeted unreliable level control equipment and modified that level control such that we could have more reliable operations that was more consistent with several other wells that we have on the site. And we could see that that was a fruitful thing as well. So just to recap some of the reporting tools before I get into training modifications. So what do we get out of these? The weekly operations report, that's the generation of those, improved our site-wide communication so that everybody from the field technician level to project management to the client, they're aware of any site-wide issues that we're running into, and that allows everybody to have an easy overview of the site operations on a weekly basis. The system operating envelopes, so this really accelerated our ability to analyze data as it was coming in each week and help to prioritize our troubleshooting efforts. Overall, we kind of saw on the last slide that this does decrease the likelihood of having unplanned maintenance, which is really a metric that we strive to maintain as close to zero as possible on the site. And lastly, our operations key performance indicators, or our KPIs, since we started tracking these, we can see that our site-wide availability is increasing by 4%. So that gives us the reassurance that we are trending in the right direction, and our focus is on using our operations reports for communication and using our operating envelopes for data analysis is trending in the right way. So lastly, the one thing we focused on in the program development was training. So our technician training schedule and competency evaluation. So every time we bring on a technician, we now have a formalized training schedule and onboarding process. So that way it's built into the program that they fully understand not just how to operate the systems, but also the purpose of them. So we integrate in that environmental aspect as well, and really hit that as a key focus to developing technician competency. The next thing is when we bring on engineering, when we bring on new engineers, we really focus on getting good communication between engineering and the technicians. And that allows us to, whenever the technicians and field personnel are highlighting an issue in the field, that engineering can come up with reliable and practical solutions. And a part of that is being able to understand exactly how field work is conducted. So within our engineering onboarding, we roped that in as well. And finally, we have multiple different discipline engineers in the project team, but as part of our onboarding and continued training, we always focus on cross-discipline training between our environmental engineers, our chemical engineers, our mechanical engineers. So that way, when we do take a look at implementing new operating envelopes or revising our operating envelopes, that we are considering fully each of those three aspects of environmental, process, and reliability. So I'll talk a little bit now about how we refine some of the reporting tools. So first, the weekly operations report. Initially, if you'll recall a couple slides ago how the initial operating reports looked, they were fairly high level. Since then, we've increased the system status, the granularity of them from just simply a weekly summary to now a daily summary to focus on, or to be able to communicate our day-to-day activities Monday through Friday. We've also added the previous month's average flow data. So this allows our environmental engineers, environmental scientists, the ability to enhance their performance analysis for particular systems week over week and relate that to a longer range look back time. We also added LNAPL recovery volumes where it's applicable. So that's a key metric of performance for some systems that we have on site. So we incorporated that as well. And then we also just added a couple of visual operational step changes and color coding to the reports. So that way we could, again, quickly analyze what seems to be more of a critical issue, and that helps our engineering teams really prioritize and focus on what should be high priority in terms of the site's strategy. As far as the operating envelopes go, we're always evaluating these and refining these to decrease the amount of nuisance excursions. So when we initially rolled these out, there was a lot of focus on just making sure that we've got the right guardrails set up. So that way, when we do have an excursion, it's meaningful and it should be something that we act upon and not necessarily something that we monitor for a lengthy period of time. So, and then lastly, our operations KPIs, as we gain more data and grow year over year, that gives us the ability to track our performance and shoot for better performing goals the next time. We also took the time over these last couple of years to refine how many categories we have within our database for why a system could be down. There are particular times where a system is down intentionally for a study or something like that. So we were able to refine that system downtime allocation to incorporate those instances so that it adds granularity and accuracy for our metric tracking as far as the KPIs go. Shown on the screen here to the left is how the operations reports looked when they were first rolled out in 2017. And to the right is how they look today. You can see that today there's a lot more detail, there's a lot more information, and this has been a lot more magnified, the amount of usefulness and practicality that we can get from these. This is a quick cutaway of the system status section of what the operations reports look like today. So you can see there's a lot more granularity. You see we've got several different additional data points in there as far as what the last month's average flow rate was. It's a key metric for the system's environmental objective. What that delta is, you can see deltas highlighted in red there, indicate that a system has achieved a pretty significant step change in the wrong direction for its average flow. So that gives the engineers an idea of maybe that's a particular system that needs to be looked at in higher priority. And you can also see how we describe issues for a particular system has also gotten a lot more detailed. This is a cutaway of the operating envelopes section and how it looks like today. So again, this shows graphically that we've done a lot of work to address a lot of nuisance excursions and then also operate and make changes to the system such that we're operating in them within those operating envelopes. And you can also see on the envelope excursion summary shown on the bottom there within the comment section, we've gotten a lot more detailed about including all the process data. So that way, when engineering goes to troubleshoot it, it's clear about what might be the issue, and they've got a starting point to go from. So I'll just touch on some of the points about where we'd like to take it from here. So first and foremost, we want to streamline the reporting process and the turnaround time for our operations reports. As I mentioned, our process data is collected weekly, but we still need some time to process that data and then put it into our reports. Our goal here is that we can leverage our existing data gathering efforts. We use intrinsically field-safe tablets. So the intention is to be able to upload that data straight to our cloud-based server, so that way we can use Power BI dashboards to directly tie into that and create to as close to live reports as we can get them. The second thing is we want to incorporate the site operating costs. So we actually want to quantify the system operating costs on the site, and this will help us to better aid in our cost benefit analysis efforts and how we choose to focus system optimization projects. So the ability to incorporate that into our reporting tools as well. And then the third one is pretty consistent with how we've been over the past 2 years or so evaluating performance. So again, evaluating the previous year's performance and setting our targets with the idea to achieve improved performance in the next year. So just to wrap everything together, just giving a quick timeline here from where we started to where we are now. So in 2016, this was really a time where we identified all the data gaps and all the opportunities that we wanted to expand the existing site operations program with the intention to just build it beyond what typical OM&M activities might entail. In 2017, we worked to develop our 3 key tools and our reporting tools to enhance our ability to perform those OM&M efforts, again, beyond what typical OM&M activities might be. And in 2018 and 2020, we really refined these tools. We focused on how do we improve them such that that the stakeholders who rely on them, that they're more practical and increase the capability and analysis capability out of them. Over that time, so we've accomplished a lot of great things. So the first and foremost Our drop in downtime and maintenance hours out of revamping our program in this way has incurred about cost savings about $120,000. So that's it can be fairly substantial for an OM&M project. And then again, hitting on our site-wide availability has increased by now average of 4%, and we're continuing to trend in the right direction, which is really, really good. So 2021 and beyond, again, the focus is really just to continue to expand the site operations program such that we can deliver beyond the typical OM&M. That way we can deliver significant cost savings and really achieve a high level of availability across the site. And we know that that is something that obviously is important to us as the OM&M supplier, but also to the client as well. So with that being said, I'd be happy to take any questions that you may have, and thank you for your time.
Thanks, Hayden. It was a great presentation. Lots of great information in there. It was really interesting. If anyone has any questions, you can enter them into the chat feature and I will read them off. Or you can raise your hand and I'll call on you and unmute you. Jeff Dietrich, you can go ahead and unmute yourself. Go ahead, ask your question.
Thanks, Jess. Great job with the presentation, Hayden. There was a lot of valuable information included in that. A lot of useful info that we can use on some of our projects here as we transition to the OM&M phase. Just a quick question for you. What software applications do we use to generate these reports? You had a lot of really nice visuals throughout that presentation. Just curious, what kind of software application do you use?
Definitely. So we're still in the process of using primarily Excel and OneNote to generate all of our weekly operations reports. As I mentioned, though, we're actively pivoting to primarily using Power BI and dashboards to directly link to our operations database. So the hope there is that, again, the goal is to decrease the turnaround time that it takes between when the technician actually gathers that weekly data to when it gets QC'd to when it's available in the database for us to run reports off of it. So with Power BI and linking directly to the database, the hope is that we cut out a lot of that time that goes into just administrative time, kind of preparing everything and then doing some still manual analysis. But primarily we use Excel and OneNote, so pretty basic applications.
Great, thanks.
No, thank you.
Let's see. How about Julian Chambert? If you can 1 second, I'll unmute you. You can go ahead and unmute yourself and ask your question.
Okay, now that works. Just a follow-up question on how long is the turnaround time between getting those weekly data processed and an operation report that you're going to be submitting, and how long you're expecting with the change you're implementing using the tablets and everything?
Sure. So currently, our technicians basically do mass data gathering throughout the week and towards the back end of a given week. So usually around the Friday and maybe early Monday time period is when that data gets processed and QC'd. And typically we'll issue the operations reports within a day of that. So overall, it's usually when we're looking at the operations report, the last data point is maybe about 2 or 3 days behind it. So that's kind of the look back time window. But going forward, really once we link directly to the database, the operations reports are really going to be just reflective of the latest data point. The idea is that we minimize / potentially cut out any kind of time we currently have dedicated to putting the report together. So it's really just going to be focused on the last data point, and that's how up to date it is.
Okay, thank you.
Thank you.
We have a question in the chat from Rangamutu. For systems that are expected to be down for an extended period of time, how do you prioritize or manage the environmental risk?
Sure. That's where, again, having one of the core goals of this entire process is to get communication across the project team and increase that communication such that we can get environmental scientists, our environmental engineers involved in the discussion with the maintenance and operations team. So that way, if there are additional fluid levels that need to be collected, if we have to do or come up with different methods of dewatering, if we see a particular issue in an area, that we can as a team be all on the same page about how to manage that risk for those situations where we incur or we expect to incur a lot of downtime for a particular system.
Great, thanks, Hayden. And I see Christy Diller. You can go ahead and unmute yourself and ask your question.
Thanks. Yep, great presentation, Hayden. I love seeing real-time and near real-time data being used to optimize fieldwork. Can you speak to how your team uses these reporting tools to prioritize day-to-day OM&M work on the site?
Definitely. So each week, our operations and maintenance team and a representative from engineering sits down and does a 3-week look ahead about where we expect to do all of our planned maintenance work, and then we'll use the latest operations reports and also the download of the operating envelopes based on the last round of data gathering, and that helps us prioritize if we have unplanned maintenance that is now incurred because we've got a system that's down. And we think it might be a pretty easy fix to get it back online. That's something that we can address as more or less break-in work, so that will come ahead of any planned maintenance activities that we had. So that allows us, again, getting back to the previous question about how do you mitigate any situations where you might have any long-term unplanned maintenance. That allows us each week to use these reports and say, all right, how does it line up with what we plan to do, and how do we need to adjust the next 3 weeks or potentially beyond?
Great, thanks.
I see Mahir Chokshi. Let me unmute you.
Hey, thank you, Jess. Hayden, great presentation. I'm going to move this into probably the next phase of data part, right? Are you guys tracking what impacts you've made to the operations, either in terms of risks eliminated, undue operations eliminated, like something in the realms of cost benefit analysis? What benefit has the client gotten? Can you give top 3 kind of benefits that you guys have identified from this?
Definitely. So one of the key metrics that we are constantly striving year over year to drive to zero is our amount of unplanned maintenance. Any unplanned maintenance we see on the site obviously is an unanticipated cost to the client, and in that way is obviously a negative thing. But some of the key things that we are able to see out of approaching the site operations this way is that we can quickly identify not only a specific issue with the system, and we can use the process data and getting our engineering team involved with our operations team to kind of quickly troubleshoot what might be the root cause why the system is going down. Is it specific to a particular piece of equipment? In which case, is there justification, is there cost benefit to either modify that piece of equipment, consider an alternative approach to the remediation objective within our scope, and overall address how can we eliminate that unplanned maintenance downtime. So the direct benefit to the client using this approach is that it keeps our focus on the metrics that we can control, typically our planned and unplanned maintenance, Because if we can drive those hours as close to and minimize them as much as possible, then the overall operating budget for the remediation site will get less and less, and that obviously allows the client to move those dollars to a different use.
Great, thank you.
Thank you.
If there are any more questions, you can either raise your hand or enter it in the chat feature. The attendance form was just shared in the meeting chat. If you're unable to see it or download it, you can send an email to daniela.savin@parsons.com if you want to get credit for today's attendance. Last call for questions. So next month's webinar will be on February 9th at the same time. It will be presented by Les Cordone and Ajish Nambiar on strategies and technologies for municipal and industrial water recycling and reuse. Thank you to everybody who joined us for today's webinar, and we hope to see you again next month.
Thank you.